All right, lesson 1.4 is about piecewise functions. And it says piecewise functions are functions defined by different formulas for different intervals of the independent variable. All right, standard notation is given in the following format. So you're going to have these different formulas or equations or expressions here, okay? So you have your first one, and then it's going to say the word if, and it's going to tell us the domain in which we would use that formula. Then we'll have a second one. It's going to say the if and the domain in which we would use that one. And then we can have more than two. A piecewise function has to have at least two of them, but it can have more. And so if we had a third one, it would be the third formula, if, and then the domain in which we would use the third one. So a really good example that we know something about of piecewise functions is the absolute value function. It's a piecewise function because the absolute value of x, remember, is equal to whatever's inside if what's inside is positive. So if what's inside is greater than or equal to 0. And the absolute value of x will be equal to the opposite of what's inside if what's inside is negative, so is less than 0. And so we can graph this. However many equations we have, that's how many tables we're going to make. And so I have two equations here, so I'm going to make two tables. My first table is going to be for when f of x equals x. And then my second table is going to be for when f of x is equal to that negative x, the second equation. All right, so back to the first table. It tells us here that we're going to use x's that are greater than or equal to 0. So we're going to start at 0, and we're going to pick numbers that are bigger, and we could just keep going and going and going. So I put dot, 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 and what that does is that reminds me that, hey, on that end of the graph, I can put an arrow. So then let's go ahead and let's finish that table. So if f of x, remember that's y, so this says y is equal to x. So if x is 0, then y is 0. If x is 1, y is 1. X is 2, y is 2, x is 3, y is 3, and we could just keep going. So I'm going to go ahead and graph that. So I've got the ordered pairs 0, 0, 1, 1, 2, 2, 3, 3, and I know that after that 3, 3, I can put an arrow because it could keep going. Now, for the other equation, f of x equals negative x, we're going to pick some x values, and it tells us here we're going to use x's that are less than 0. But be careful because negative 0.000001 is less than 0, but we can't graph that x value. So what we're going to do is we're going to include the 0 in our table, but it's not included, so that means we're going to graph it with an open circle. So I'll put a big open circle around it to remind me that when I go to graph it, oh yeah, open circle. And then I'm going to pick numbers that are less than 0, so negative 1, negative 2, negative 3, and we could keep going again. So if f of x is equal to negative x, then remember that's y is equal to negative x. So my y here is equal to negative, the x value, which is 0, and the negative 0 is 0. Then it's going to be equal to negative x, which is a negative 1, so negative negative 1 is positive 1. Then negative x, which is negative 2, negative negative is positive 2. Negative x, which is now negative 3, negative negative is positive 3, and we could just keep going. And so let me plot those points, but notice 0, 0 is going to be an open circle, and it's okay that there's already a closed circle there, okay? It just means that point is included in our graph, but it was included on the right side, not the left side. And then we got negative 1, 1, negative 2, 2, negative 3, 3, and we know that when we draw this line here that our arrow would show that we could keep going. And so there's our absolute value function, graphing it using piecewise functions. So, and we know from Algebra 2 that an absolute value function is graphed as a V. So it asks us, is the function above continuous? Yes, this one is continuous. We can draw that function without lifting our writing utensil. State the domain and range. Well, for the domain, the graph keeps going to the left, the graph keeps going to the right, and we don't have to lift our pencil. So that means it's negative infinity to infinity. But the range, it does not keep going down. So the range, notice the lowest y value is at 0, where it's equal to, and then it does keep going up to positive infinity. And then where is the function increasing and decreasing? Well, we're increasing, we're going up, starting at the vertex there at 0, and we're going to keep going up until we go all the way to the right, which is positive infinity. And then where is it decreasing? Well, it starts decreasing on that far left, which is negative infinity, and it keeps decreasing into that 0. So another piecewise function that we're going to look at is called the ceiling function. And so what do you think of when I say the ceiling function? You probably think about the ceiling in the classroom or in your bedroom or the ceiling up above, right? So notice the notation. It looks like it's a bracket there, but if you notice, it only has the top part of it, okay? And that's because, oops, sorry, didn't mean to draw the bottom. That's because it's a ceiling function. It's above. So everything we're going to do is about going above. And so it says f of x is equal to, it shows that symbol there, where that symbol means the least integer greater than or equal to. Let me spell that. X. All right, so what this means is that we are going to round up when we do this, okay? So if we're looking like at a number line, and I'm looking at between the numbers 2 and 3, I have the number 2.5. If I'm looking for the greatest integer, or the least integer greater than or equal to 2.5, I would round up, so I would say that it is 3. So let's make a table here. And it's going to be a little bit longer table than we're used to. So I'm going to pick some x and y values. And at first I'm going to pick some values. I'm going to pick several values in between some decimals here. And then as I get towards the end of my table, then I'll just kind of use one in between. So it tells us to go from -3 to +3. So I'm going to pick -3, -2.9, -2.1, -2, -1, 1.9, -1.1, and -1. -0.9, -0.1, 0. And then I'm going to pick 0.5, 1, 1.5, 2, 2.5, and 3. Because by the time we get to graphing those at the end, we're going to already see our pattern. All right, so the least integer greater than or equal to -3. -3 is an integer, so it's going to stay -3. The least integer greater than or equal to -2.9, we're going to round up. -2.9 rounds up to -2. -2.1 will round up to -2, and -2 is an integer, so it's going to stay -2. -1.9 will round up to -1. -1.1 will round up to -1, and -1 is an integer, so it's -1. -0.9 will round up to 0. -0.1 will round up to 0, and 0 rounds up to 0. If it's hard on you to do the negative numbers, guys, draw yourself a number line and look at where it's at. And remember, round it up to the next integer. So 0.5 would round up to 1. 1 will round up to 1. 1.5 rounds up to 2. 2 is an integer, it stays 2. 2.5 will round up to 3, and 3 will stay 3. All right, so when we go to graph these, now, it said -3 is going to be an open circle. I'm not going to graph this point just yet, okay? So I'm going to wait on it. But I'm going to do -2.9, -2, -2.1, -2, and -2, -2. So what's going to happen here is I'm going to connect these lines, but I didn't put it on my table, but what about -2.9999999999999? That's going to round up to -2 as well, okay? So I could have added that in here. Could have said -2.9999, and that would still be -2. So how do we symbolize that on our graph? Well, on our graph, that means -3 does not round up to -2, but we're going to put an open circle there, meaning -3 won't round up to -2, but the number right beside it there will. And so you'll see we got an open circle at -3, and it's going to be a straight line all the way to the closed circle at -2. Then -1.9 will be -1. -1.1 is -1, and -1 is -1. Well, again, what about -1.9999? That's also going to be -1. So at the -2 there, we're going to put an open circle and connect those points. So we have an open circle at the -2, closed circle at the -1, and all the x's in between them are included when y is going to be -1. And so you can probably start to see a pattern here. But let's see, we got, what's that, -0.9 is going to be 0. -0.1 is 0, and 0 is 0. Again, what about that -0.9999? That's going to be 0. So at the -1 there, we're going to put an open circle, and every point in between that and when x is 0 is going to be 0. Now we can kind of see our pattern. It looks like a bunch of steps. And so when we go to graph the next one, what is it, 0.5 is going to be 1, and 1 is going to be 1. Well, we know then that means this is going to be an open circle, and these are connected. 1.5 is going to be 2, and 2 is going to be 2. Again, open circle at the 1 and connect them. And then 3 is going to be, where am I at? I'm sorry. I got to do 2.5 is going to be 3. And 3 is going to be 3. Again, the 2, we're going to put open circle and connect those points. And so this is the ceiling function, okay? It's where we round up. So the next function we're going to talk about is really similar to it. It's called the floor function, though. And so the floor function, notice it has the little braces on it, the bracket, excuse me, and it only has a bottom part because it's where the floor is. The floor is down below, so it's going to use the bottom part. We're going to round down on the floor function. So it says f of x equals, and it's got the symbols there, where those symbols mean the greatest integer less than or equal to x. And so for here, we're going to round down. And so I'm not going to make our table quite as big. I'm only going to use the 0.5s and the integers this time. And it says go from -3 to 3. Okay, and so remember we're going to round down, and if you have trouble again, look at a number line. So -3 is an integer, so it's going to stay -3. -2.5 is going to round down to -3. -2 is going to be -2. -1.5 rounds down to -2. -1 is an integer. -0.5 will round down to -1. 0 is an integer. 0.5 will round down to 0. 1 is an integer. 1.5 will round down to 1. 2 is an integer. 2.5 will round down to 2, and 3 is an integer. So when we go to graph this, we've got -3, -3, and then -2.5 is -3. Well, again, I didn't put it, but what about -2.0001? That would also round down to -3. So what we're going to do is right here at the -2, we're going to put an open circle because it's not included, but the number right next to it is. So then we have 1.5 is -2, and hold on, lost my place. -2 is -2, and -1.5 is -2. And then the same thing, we're going to put an open circle right there, and every number under that will round down to -2. -1 is -1, -0.5 is -1. Well, anything that's between -1 and 0 will round to that -1. And so we can see our pattern here. And so we can go ahead and graph our other functions. And then we don't actually have to graph the 3 because it says in here that the 3 is not included. And I can see in my graph right there that the 3 is not included. All right, and so this is the floor function. Look at how it differs. It looks the same except for now my closed circles on the left and my open circles on the right. The smaller numbers included because we're rounding down. So there's our floor function. It's another type of piecewise function. All right, so evaluating piecewise functions. So here we're given this piecewise function. And notice it's got three different equations. It says we're going to use negative 2 times the absolute value of x plus 1 anytime x is less than 1. We're going to use the fact that it's equal to 2 anytime x is between 1 or 3, or if 1 is less than or equal to x less than 3. And we're going to use a third equation there, 5 minus 1 half x, anytime that x is greater than or equal to 3. So look at A. A says f of 12. Well, remember that x value then is 12. 12 is greater than 3, so that means we're going to use that third equation there. So we got 5 minus 1 half times our x, which is 12. And so we're just going to work that out. And we'll get our answer. B is f of 2. Well, x is 2. So look up here. 2 is between 1 and 3. So it equals 2. We don't have anything to plug it into. There was no x value in that equation. It was just a 2. And then C says f of negative 5. Well, x is negative 5, and negative 5 is less than 1. So we're going to plug it into that first equation. So negative 2 times the absolute value of negative 5 plus 1. So we got negative 2 times the absolute value of negative 4. The absolute value of negative 4 is 4. Times that negative 2 gives us the negative 8. And then D says f of 0. Well, that means x is 0, and 0 is less than 1. So we're going to plug it into that first equation. So negative 2 times the absolute value of 0 plus 1. So we got negative 2 times the absolute value of 1. So negative 2, and the absolute value of 1 is 1, times that negative 2 is negative 2. Then we're evaluating again here. So we're going to use that top equation anytime x is greater than 2, and the bottom equation anytime x is less than or equal to 2. So the first one we're doing there, A, says f of 6. So that means our x value is 6, which is greater than 2. So we're going to plug it into the 3x minus 7. So 3 times 6 minus 7. So work it out, and we get 11. B is f of negative 3. X is negative 3, which means x is less than or equal to 2. So we're going to use the second equation. So we're going to have negative 3 squared minus 1, which is 9 minus 1, which is 8. Alright, so the next part here is going to be name that graph. So now they've given us a graph, and we're going to write the piecewise function that represents it. So for A here, notice we have 3 different pieces on our graph, and we have 3 lines to write our equations. So when we look at this first equation, or excuse me, this first line, notice it's linear, so we're going to have a linear function here. So I can find my slope, which if I pick 2 points and go between them, I'm going to go down 1 and right 2, so my slope is 1/2. And my y-intercept crosses the x-axis right, the y-axis right there at 5. So I know my equation is going to be 1/2 x plus 5. Now when do we use that? Well, let's look at the x values. It keeps going to the left, so we know that x is going to be less than, so less than where it starts right here, which is at 2. So now, is the equal to at the 2? Well, look at the point on that. It's an open circle, so it is not equal to. So that's our first part of it. Then the next one is just this line right here. So if we notice it, we could tell it's linear as well. Our slope is 0. If we pick 1 point and go to the next one, we go up 0, right 1, which is just 0. Alright, if I go to my y-intercept, I'm going to have to continue this over here, and I can see my y-intercept then would be at 3. So that equation will be 0x plus 3, but do we have to really put the 0x? No, so we could just say it is at 3. Then we got to give the domain for it. When are we going to use that one? Well, we're going to use it from 2 to 5. So 2 less than x less than 5. And then check, is it equal to at the 2? Yes. Is it equal to at the 5? No. So there's our second equation. Now let's move on to the last one there. This one here. So we can look at it. It's linear as well. So we can see our slope. If I pick 2 points, going down 1, right 1. So down 1, right 1, which is negative 1. Now our y-intercept, we're going to have to work a little bit here. So we could go up 1, left 1, 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 right there, which is going to be at 7. So our equation is going to be a negative x plus 7. And then for what x values do we use that equation? Well, we can see it keeps going to the right, so we know our x's are greater than that number right there, which is 5. And is it equal to the 5? Yes, because it's got that closed circle. So there is our piecewise function that would give us the graph that we have below. So let's do the same thing for b. So on b, notice this first part here is a quadratic, and it's a quadratic that's been moved down 3. So we could say that it is x squared minus 3. And where do we use that at? Well, it keeps going to the left, but notice it starts right here when x is 2. So since it keeps going to the left, it's less than. And we got 2, and is it equal to at the 2? Well, it's got that closed circle, so yes, it is. The second part is another horizontal line, so we know that our slope is going to be 0, and we can go back across and see that our y-intercept is over at negative 2, so we know it's going to be 0x minus 2, or just negative 2. And we're going to use that from our x values from 2 to 5. So 2 is less than x less than 5, and is it equal to at either end? No, because they both have open circles. And then the last piece of this one is right here. So we can tell again it's linear. So we can see that our slope is up 1, right 1. So that means our slope is 1. And then we can just go backwards here to be able to see what our y-intercept is. So it's going to cross the y-axis right there at negative 3. And so we get the equation, which is x minus 3. And where do we use that at? Well, let's look at those x values. They keep going to the right, but notice they start there at 5. So because they're going to the right, they're getting bigger than 5. And is it equal to the 5? Yes, it is. So put the equal to sign there. All right, so that's how we can pull the graphs and be able to write the equations for them. So let's go ahead and let's graph one more. This one's a little fun, so we can use our calculator to help us, only to help us with the table. Okay, we still need to write out our tables, and I do expect in your assignment to see your tables. So let's use our calculator to help us though with the tables. So the first one I'm going to do is negative 1/2 times x plus 4 squared plus 3. And when I go to do this, I can see that it's telling me I'm going to use x values less than or equal to negative 1. So I'm going to use negative 1, 0, oops, sorry, wrong way, negative 2, negative 3, negative 4, and we could keep going. But be careful because this is quadratic and it opens down. I know it's going to be a piece of this, and I probably need to make sure that that vertex is included if possible. So I may have to add some more numbers onto my table here, okay? So I'm going to go to my calculator and I'm going to type this in. I'm going to go to my y equals. Then I'm going to go to my table and look at it. And so I can see that when x is negative 1, it says it's negative 1.5. And negative 2 is 1. And negative 3 is 2.5. And negative 4 is 3. Now notice the difference in these is getting smaller and smaller, which means I'm getting closer to that vertex. So I want to keep going. So I'm going to do negative 5, which is 2.5, because these are repeating, and that means this is my vertex, okay? So I've got enough there I can graph it, and so I'm going to go ahead and graph that. So we got negative 1 and 1.5, negative 2, 1, negative 3, 2.5, negative 4, 3, and negative 5, 2.5. So we can see that vertex there. And I know that I could have kept going on this side, so I'm going to put my arrow over there. All right, for the second graph. Now, I'm going to erase my table only because I don't have room to write them all up here, okay? But you don't erase yours. You need to keep them. So for my second one here, I get 3 times the absolute value of x minus 2 minus 4. So we're going to make a table for it. And it says we're going to use x's from -1 to +4. Now this one, even though I know it's absolute value and it's going to make a v, I don't have to worry about including that vertex because it told me I have to go from -1 and I have to stop at 4. So I know a start and stop point, so I don't have a choice. Now I am going to notice that the -4 is not included. So I'm going to go ahead and I'm going to put an open circle over here at the 4 so that I don't include it. Alright, so I'm going to go back to my y equals. Now remember, I'm going to type in my 3. We get absolute value by going to second 0 and choosing abs. And then I'm going to do x minus 2 and then minus 4. Go to my table. At -1, I see 5. 0 is 2. 1 is -1. 2 is -4. 3 is -1. And 4 is 2. And because they're repeating themselves, I can tell that it includes the vertex. But remember, on this, because it told us where to start and stop our table, we just have to use the numbers in between. Alright, so I'm going to graph these. I got -1, 5. Oops, and I didn't notice. I almost messed up. The -1's not included either. So I need to put an open circle there as well. So -1, 5. 0, 2. Whoops. Wrong way. Sorry about that. 5, 0, 2, 1, -1, 2, -4, 3, -1, and 4, 2. That's an open circle. And then I'm going to connect those points. And then the last one there. For my last table, it's going to be x minus 6 cubed plus 2. Now remember, think about the shape. This is a cubic, so remember it's going to have that little squiggle kind of in the middle. So it's going to look something like this or something like this. I got to make sure I see the little squiggle if it's included in that part of the graph. So we're going to do the x minus 6 cubed plus 2. We're going to make ourselves a table. And it tells me to use x values greater than or equal to 4. So 4, 5, 6, 7, 8, and we could keep going. So let's put this in our calculator. Go to our table. So I got 4 is -6, 5 is 1, 6 is 2. Notice how the numbers got closer together. There's my squiggle. 7 is 3. And 8 is 10, further apart, so I came out of that little squiggle there in the middle. Alright, so I'm going to graph them. So 4 is -6. 5 is 1. 6 is 2. 7 is 3. And 8 is way off the graph up there at 10. Remember, I don't keep going down to the left. It started there, so I only went up to the right there. Alright, and so there is our piecewise function. And so I'm going to stop this video. I'm going to call it part 1, and then we'll continue on in the next video with the rest of the lesson.